Yeah, good morning, students. It is a part, actually, it is four. Huh? Right. We will continue the exercise 4.1. Okay, now it is already we solved four problems. Now I am going to continue and solve the problems. Fifth one. One. This is, you see, the Roman one. It is 3 minus 1 minus 2. 0, 0, minus 1. 3 minus 5, 0. What we are asking in this exercise means, in the fifth problem, we have to evaluate. Simply, the previous problems are also. We are not given directly the matrix. Directly we are given the determinant notation with the matrix. This is not matrix. Actually, this is not right. But here it is matrix. Separately a matrix is given, then we are asked to find a data. But here is simply, it is a notation for the determinant. It is plus 3. Every day you try to understand it. This is plus, it is minus, again it is plus. Don't confuse of this minus 1, that is a different one. Whatever it may be, it is element. 3 is element, minus 1 is element, minus 2 is again element. Plus, minus, plus we have to consider. Plus 3 into that row and column deleted, we get 0, minus 1, minus 5, 0. Okay, now? And then you write minus, and then you write the element minus 1. Don't confuse. Minus already must be there. Plus, minus, plus. 3 minus 1 minus 2. So minus 1. If the row and column, this row and column deleted, we get these elements. And 0, minus 1, 3, 0. Okay, now? Next. Plus, this is minus 2 with the determinant row and column deleted 0, 0, 3 minus 5. 0, 0, 3 minus 5. Okay, now it is 3 into 0 minus of minus 5 minus 1. Minus 5 minus 1 is there. This is minus into minus plus 1 half. This is 0 minus 3 into minus 1. It is minus, plus into minus is minus 2 half. 0 into anything is 0, minus 0 into anything is 0. This is 3 half. Minus into minus into minus. 3 minuses are there. So at last we get 5 into 1, 5 only. 3 minuses is minus 5. And here it is minus plus 3 is there. This is 0 only. So minus 15 plus 3, that is minus 12 is the determinant of that matrix. Okay, then next we'll go to next. What is determinant 2 minus 1? It is minus 2. And 0, 2 minus 1. It is 3 minus 5, 0. Here it is, here also the same thing. It is plus, minus, plus. Whatever it may be the sign of elements, you don't confuse. You take plus, minus, plus always. This is plus 2 of row and column deleted. Here it is 2 into 0 minus 5 into minus 1. Okay, now? Minus 1 of minus must be there. Element is also minus 1. Here it is, by deleting this row and column, we get this one. 0 into 0. Directly I am solving it. Minus 3 into minus 1. Okay, na? It is 1. Next, plus 2 into plus of minus 2 is there. Minus 2 into row and column related 0 to 3 minus 5. 0 into minus 5 minus 3 into 2. 3 into 2. Now it is 2, this is 0. Here 3 minuses. 5 into 1 is minus 5 is there. Minus plus 1 half. Again 0 plus 3. 3 is there. This is minus 2 of 0 minus 6. So it is minus 10 plus 3 minus plus 12. How much? 15 minus 10 is 5. Okay, Nana? It is arithmetic. You see once again. Is there any mistake? You will see. 2 of 0 minus 5. Yeah. Minus 1 of 0 plus 3. Yes, okay. Minus 2 of 0 minus 6. Yes. This is plus 12, 3 and minus 10. We get this one. Okay, now? Now, sixth one. Right. Sixth one. We are given a matrix. Capital A is equal to, it is 3 by 3 matrix. 1, 1 minus 2. Okay, now it is 2, 1 minus 3. 5, 4 minus 9. It is a 3 by 3 matrix. Yeah. Now, we are asked to find det A. Then, det A means determinant of A is, with notation you write it once again. The same elements can be written in this way. It is, once again I am telling, it is a plus minus plus. Whatever it may be the elements, the sign of elements, you leave it out. Plus minus plus always. Plus 1 into, actually row column we get 1 minus 3, 4 minus 9. Minus 1, the row and column deleted. These are the elements. 1, that is 2 minus 3, 5 minus 9. Okay, now plus minus 2 into the determinant. Row and column deleted. These are the elements. 2, 1, 5, 4. Okay, now once again you see that. Plus 1 into that row and column deleted. We get these are the elements. 1 minus 3, 4, 9. Minus 1 row and column deleted. 2 minus 3, 5 minus 9. And plus into minus 2 of the minor row and column deleted. 2, 3, 4, 7. Now it is 1 of, this is minus 9 minus 12. Minus 1 of minus 18 minus 15. Minus 2 of 8 minus 5. Okay, now 1 into minus 9 minus 9. Minus 4 into minus 3 minus 2. Again, minus 1. Here also. 2 into minus 9 is minus 18. Minus 5 into minus 3 minus 15. This is minus 15. Okay, now. Plus minus 2 of 8 minus 5. Now this is 12 minus, this is plus 12 minus 9 is 3. This is minus 18 plus 15, minus 3 is there. Minus 2 into 3 is there. 3 plus 3 minus 6, that is 0. Okay, na? So the data of this matrix is 0. Okay, na? Right. Next, is it clear? Yeah. Seventh one. I'm taking seventh one. Find the value of x if we are given the condition. Given. What is given? The condition is the data of 2 by 2 matrix 2, 4, 5, 1 is equal to the data of 2x minus 4, 6, x. The expansion of this 2 by 2 determinant 2 into 1 minus 5 into 4. This is 2x into x minus 6 into 4. 2 minus 20, 2x square minus 24. Okay, now this minus 18 is 2x square minus 24. 2x square, that is. This is 24 minus 18. I am writing 2x square in LHS. This is how much? 24 minus 18 is 6. X square is equal to 6. What is x? Root 6. Sorry. This is 6 by 2 means 3. This is plus or minus root 3. Like that. Once again you observe. We are given this condition 2, 4, 5, 1 is a determinant 2 by 2 determinant 2x 4 6 x is 2 into 1 2 minus 20. This is 2x into x 2x square minus 6 4 24. This is minus 18 2x square minus 24. That 24 sent to this side. 24 minus 18 that is 6. This is 2x square. 6 by 2 is 3. X square is equal to 3 means x is equal to plus or minus root 3. Okay now? Right. And the last one. Here also you observe me. Here one more problem is here. Second problem that is given to us homework. This is homework. And here also there is 2 is there Roman and 3 is there. These two problems is given as a homework. Now the last problem. What is the last problem? It is update to none. 8th one. If the mod of x to 18x is equal to the determinant 6 to 18, it is 6. Here also, same, method is same. We are given the condition, that is, the LHS, it is a determinant of 2 by 2 matrix. There also, determinant of 2 by 2 matrix. That is, x into x square minus 18 into 2 is 6 into 6 minus 18 into 2. It is x square minus 36. 36 minus 36. Cancels, we get 0. So x square is equal to 36. Okay now? Then x is equal to root 36. That's it, plus or minus 6. So the answer is, the option is B. Okay now? Like that. It is over. Yeah. Okay. Students, the exercise is completed. Again, we have some properties. Okay now? In this determinant, slowly we are solving the properties, definitions, formulas. Not formulas, only definition, and one method is given. Okay, now properties you have to by heart and keep it in your mind. Practice it well. Directly the questions will be given like that only. By using the properties in the exercise, we will solve the problems. Okay, the 4.1 is completed. Now we are going to solve the property. There are three properties are there. It is important one. Slowly you learn it then. The property. Already two properties were. Now third one. If any two rows or two columns of a determinant are interchanged, then the sign of determinant changes. Means, suppose this is a determinant. Determinant given. It is a determinant. In this determinant, if two rows or two columns, any two rows or any two columns are interchanged, then that determinant will be changed by only sign. Sign with SI here. Plus, if a plus is there, suppose this value is plus 24. After interchanging the rows or otherwise columns, then its determinant value is minus 24. Okay, na? Like that we have to prove. That is the statement. The determinant in the determinant are interchanged. Any two rows or columns of a determinant are interchanged. If they are interchanged, not by rows, columns, that is a different first property. That is a different one. Don't confuse with yourself. That is a different one. If rows and columns are interchanged, that is transpose. Then determinant will not be changed. That is a different one. But if two rows, row 1, row 2 are interchanged, then the sign will be changed. Or two columns, column 2, column 3 interchanged, then the value will be sign only changed. That is the statement. Now, you see, we will prove it. Student, observe. Here, delta is also the notation for a determinant. Delta is also notation for a determinant. Delta is equal. Here, very simply I am taking A1, not A11, A12, A13. It's simply A1, A2, A3. The A's are related with the row. B's second row. C's third row. And 1, 2, 3, it is related to column. So different elements, the positions are different ways. Okay. What is its expansion? Already we know it. This is plus, minus, plus. A1 of, many times we solve. A1 of B2 C3 minus B3 C2. Try to understand it. A1, that row and column deleted. These are the minor. B2 C3 minus B3 C2. Again minus A, minus A2, minus A2. That row and column deleted B1 C3 minus B3 C1. Okay now? You see my hands then. Minus A2 into this row and column deleted B1 C3 minus B3 C1. Okay now? Right. Again plus A3 row and column. That row and that column where the A3 is lying. That row and column deleted, the remaining elements are B1 C2 minus B2 C1. Okay now? That is the value of determinant. It is equation 1. Leave it off that one. Again we will consider, you see that, after interchanging, here you see, A1, A2, A3 is the first row, that will become as a second row. B1, B2, B3 is the second row, but it is changed as a, here we applied. What we applied? Because you see that R1 interchanged as a R2. R1 and R2 interchanged. Since R1 R2 interchanged, we get this one. Okay now? Now, this determinant, it is in determinant only. This determinant, by using the same, it is plus minus plus. B1 of, say, row and column interchanged, Deleted only A2 C3 minus A3 C2. Okay na? Minus B2. Row and column interchange. Deleted, these are the elements. A1 C3 minus A3 C1. Okay na? Yeah. Plus B3. B3 is there. B3, that row and column deleted, we get only these elements. A1 C2. A1 C2 minus A2 C1. Okay na? Here we have to expand all the brackets. B1, A2, C3 na. You maintain one thing there. A, B, C. A, B, C. Whatever it may be the suffix. The order A, B, C must be maintained. And the suffix order not possible. So A2, B1, C3 minus A3, B1, C2. Here also A1, B2, C3 minus C2 minus plus A3, B2, C1 expansion. Here also A1, B3, C2 minus A2, B3, C1. Okay na? Yeah. Now, in this one, slowly try to understand it. First, I want to take A1. Where A1 is there, here A1 is there, and again here A1 is there. Okay na? So, first I take plus A1. Plus A1. So, B3 C2 na? Here B2 C3. B3 C2 minus B2 C3. Yeah. Minus. And again, A2 I want to take. Here A2 is there. And again here A2 is there. From these two, first and last, minus A2 I am taking the common. Don't confuse. Minus A2 means first you write B3 C1. Minus, because minus is there. Minus B1 C3. Okay, right. The next only two terms are there. In that two terms, the common is A3. Here A3 is there. Here also A3 is there. Plus A3 I want to take common. B2 C1 minus B1 C2. Okay then? You remember one thing. In this type of problems, you see one order is there. B3 C2 na B3 C2 3 2 2 3. B3 C2 means B2 C3. Here also B3 C1 means B1 C3. 3 1 1 3 2 1 1 2 like that. Now in this expression I want to take the common. You see that if you interchange this in the bracket two terms, it is x minus y minus x, we get minus. Alpha minus beta, beta minus alpha, I am writing. So minus will come. Here also, some, this is L minus M. M minus L, we get a minus. Okay, na? In the bracket, the terms are interchanged. So, we get a total minus. Total minus. Now, A1 off. Okay, na? The minus is there then. So, it is B2 C3 minus B3 C2. Similarly, in all the terms. Okay, na? Like this. The minus is taken common. In the brackets, the terms are interchanged. B2 C1 minus B1 C2 means B1 C2 will come. Minus B2 C1. Okay, na? Right. That is minus into this term, this expression is just like, see, you verify them. A1 is there, A1. B2 C3, B3 C2. Yes, correct, na? Minus A2 of B1 C3 minus B3 C1. Same, B3 C1 is there. Plus A3 of B1 C2 minus B2 C1. Or otherwise, you write here B3 C1. Here also, it is B2 C1. Okay, Rena? Same thing is there. So, by using, because it is from the equation, we get a det. So, it is a minus det. So, we consider, what we consider the given determinant. In the given determinant, R1 and R2 are interchanged. We get the value minus that here. Okay, now, similarly, if we want to change two columns, then also we get the same thing. Hence the theorem. Okay, now? Right.